Okay, reverse linked list 2. Oh, it was a long time ago that I did the reverse linked list, so I don't even remember. Okay, given the head, 2 integers left and right. Okay, we only want to reverse the nodes from left to right. Okay, instead of the whole list. Position left, position right. Okay. And this position is 1 indexed, 2 to 4. Okay, 5 left 1. Okay. So link this, we want to reverse from position left to right. Okay, so we first traverse until we reach index left, and that's where we need to start the reverse until we have done just enough, and then we leave then we connect the rest of the list. Okay. So we want to first get to the left position. So if left is 2, we want to we still need to have a pointer that's pointing to the one before where we're gonna reverse. So we can do that next. So when so on left is 2, we actually did not need to go any steps. Let's see. Let's have one pointer called before. So before will be pointing at the node before where we need to reverse. So we could do before next and then connect the reverse list. So for left, for int, do we want to? Oh yeah, we need to save the head as well. Because we need to return the head, so we need to save the head. So let's have node, use node. Okay, so for this example, it did not need to go next at all. So before it's still pointing at 1. Okay, so we found where we need to start reversing now. So the first node we need to start reversing is actually gonna be before next. Okay, so we are at 2. So we need to reverse 2, 3, 4, 2, 4, 3, 2. And how do we do a regular linked links reverse again? Do we need to separate this part out first? Okay, let's not do that first and see if it works. So we need to reverse all the pointers. So they will be pointing this way, I'll be pointing this way, and then we do 1 next is 4, and 2 next is 5. So we node is at 2 right now. Well, okay, let's refactor this later, but let's have a count. Well, count is so this way we're gonna go 2 times forward. Okay. We need to save. Okay, we need to save node next, which is 3. And save next is node. Oh wait. Oh, I can't remember how to reverse a linked list. Oh my god. Okay. Okay, let's just look at 2, 3, 4. How do we reverse this? We need to save this node before we remove this pointer. So save next is node. And 3 is saved. And what do we do then? Okay. node, save. Okay. Okay, let's try another thing. Let's say, okay, we have node and save. What if this is node 1, this is node 2? We're saving node 2 next, we're saving 4. Node 2 next is node 1. And then node 1 is node 2 is save. Okay, so we're at node 1, node 2, this is save. So node 2 next is node 1, and now node 1 is 3 and node 2 is 4. For the next round, okay, this is node 1, this is node 2, save would be that next, it would be 5, but we actually need to cut off here. Node 2 next is node 1, and node 1, node 2. Okay, so we actually only needed one loop. Okay. We also need to, the first loop we need to do node 1 next is null. Node 1 next is, how do we do that? Okay, node 1. Oh, what do we have here? Okay, node 1 and 2 and save. Oh, right. Okay, let's start with null node, node 1, 2 is here. Okay, start with a null, a pre-node, and then node 2 is pointing here. Save is pointing at 3, so 2 next is null. Then we move forward. Node 1 is here, node 2 is here, save is here, 3 is pointing to 2, and then it moves forward. open into and save. Two, next is one. Oh, so this actually needed 3 times. We needed to change this pointer, and that pointer. And the last time the save, we actually need to cut off here. Okay, so the last round will be node 1, node 2, save. So node 2, next is 3. Okay, and save is at 5, but after the loop, we save is at node 2. So we need to do connect this and connect this. So we had before next is equal to, we need the end. Okay, so that would be node 1 here. And we need this one, that was the first one, to be pointing to this node 2 right now. And do we have that saved somewhere? That was the first node. We might need to have an extra node. Okay, let's save another variable. So we are saving this to be so before is pointing at this. Oh wait, so before it's there, node 1 starts out at null and node 2 is before next. So do we still have before next? Or okay, 1, 2, 2 next is okay, that's gone. 2 next. Oh wait. So start with null and 2. 2 next is null, but before next, that's not changed, so that's still there. Okay. So before next is null node 2. So 2 is this should be before next, and the next should be node 2, which is the last save, and before next should now be node 1. This is node 1 in the last round. Okay, and we want to return head. Let's see if this works. We might be missing some details Oh, it's already taken 20 minutes. Before, head, next. What happens for example 2? We have one node and node 2 is null. Null. Yeah, it's called null. Null. Null would be Swedish. Null. 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 I need to figure that out. Okay. Why would we encounter this object reference not set to an instance? That's usually the case when we have a null node So here we would okay, so this for instance would cause it to return error because node 2 is already null and now we're calling node 2 next. Okay, so what if we do oh wait, so I mean if left is equal to right, then we are only traversing one single node. We could just return altogether. Okay. Three, 5, 1 to 2. So we wanna basically just reverse 2, 5, 3. Okay, so 1, 2. We would run 2 times in this for loop. Have 3 and 5. Left -2, so nothing's gonna happen there. Okay, let's say we have 3 and 5. Let's just imagine it being to the left here, 3 and 5. Okay. So node 1 would be null, node 2 would be head next. Okay, I see the problem. So in this case, before is the head, and now node 1 is null, and node 2 is head next, which is not what we were looking for. So when we were here, for example 1, we had before is the head, and node 1 is null, node 2 is this, which is what we want. But if left is 1, well, if left is 1, then we do not need to do all of this. what if left is 2? Then this does work. Okay, if left is 1, we want node 2 to just be before. Otherwise, we want it to be before next. That did not solve it. 3, 5. Okay, let's step through again. Before is pointing to head, left is 1, so this is not gonna run. So node 1 is null. Left is 1, so node 2 is same as before, so it's head. So null and head. And now we only have a 3 and a 5. Let's say we have 3 and 5 here. So node 1 is null. Node 2 is at head, which is the 3 here. Let's say this is 3. That's gonna be 1, so it's gonna run twice. Okay, so save would be at 5. So we have node 1 null, node 2 at 3, and and save at 5. So node 2 next is node 1. Okay, so 3 next is not null. Node 1 is not at 3, and node 2 is now at 5. And now save is at 5 next, so save is null. Node 2 next is 3. So node 1 is pointing at 5, and node 2 is pointing at null. And before, before was still the head. So head, next. Something's not good here. So before, next. So the head, which is 3, next is already null, so it cannot do next. So how would we fix this case? Before, next is node 1. Before, next is node 1. And are we returning? No, we will be returning 5 as the head in this case, and 5 would be Oh, if it starts reversing after the first one, then we are returning head, but otherwise return well, if left is bigger than 0, if left is bigger than 1, then we are returning head. Otherwise we are returning the end of so which was the last one again? Should be node 1. Okay, node 1. Still not correct. Out of memory. Out of memory. Okay, let's just write down some values. I am practicing to stop using Visual Studio when I try to solve these problems. Rather, I'll just print out within this editor to see if I can help. Okay, 355. 355. It's interesting. But how come it's no longer out of memory? Okay, we have 3, 5, and then node 1 is 5. And node 2 will be null. So these two loops actually worked, but why would it be having another empty problem? I'm back. Okay, so if we had 3, 5, node 1 is first null, node 1 is then 3, and then node 1 is then 5. Before okay, so it worked for those. Null reference. Oh, that's just okay. Oh my god. Really losing it. Oh, it's something wrong with this? Wait. Oh, my headache is killing me. Out of memory. But wait, this if left. Why is it out of memory? We are done with the for loop and we are also. Oh, okay. So we never got this. Okay, but we are already here and then it's out of memory. If left is bigger than 1, which is not, otherwise turn node 1, node 1 should be pointing at 5. Why isn't it? Returning 5. this is also just one pass. Why is it out of memory then? Okay, I must be missing some pointer. Maybe it's not pointing at null. Three and 5. 3. Or 3 is pointing at null. Head is 3. Oh, I actually do not know. Okay. Alright, I have to check this in Visual Studio. Fortunately, we had okay, 3 5 1 2. 3 5. Okay. Okay, so it's run. Now we have 5 3 5 3. So 3. Oh, that's weird because I was so sure that 3 was pointing to null. Why isn't it pointing to null? Okay, so we have 3 and 5. Node 1 is null. Node 2 is left equal to 1. Yes, then it's pointing to head, which is 3. Okay, first round. We're gonna do 2 rounds. First round save is 3 next, so save is at 5. So we have null 3 5. Null 3 5. Node 1 is null, node 2 is 3, save is 5. Node 2 next is node 1, so 3. Next should be null. That's where it should happen. Oh, so before is at head and before next has just not be connected to node 1. Otherwise, before next is still null. Some progress, but still not quite there. Okay, output 213. 1, 2, 2, 1, 3, but I only got 2, 1. So, okay, left 8's 1, so it got null. So this is not the correct condition to check. So when will we have null? That should be when there's nothing left here, when the last one in the reverse list is the end. Before next. Okay, so 1 shouldn't before next be node 1 when we had 3, 5. Okay. Oh my god. Okay, to take a rest. I'm literally falling asleep sitting here. Okay, let's focus. We're almost there. It's almost been an hour, so I've already filled the interview anyways. Or not, maybe they would have given me some clues, so it would have sped up the process. Okay, last thing we need to figure out. So before next, when we had 3 and 5, so the whole list needed to be reversed. We did not do before next is node 1. Wait. Okay, so we have 1, 3. 1, 2, 3. It got 2, 1. and before is pointing at 1. Before next is null. So in this case, before next is null, so we did not get this part connected. That's the problem. So before next is null. That happens once left is equal to 1. So when left is equal to 1, before next will be null. And that's when we fail to connect this. If before next is not null, we do that. Else, if it is null, then what do we need to do? If it is null, then we have head next is node 2. Okay. Still incorrect. Okay. Oh, I really don't want to step through one more time. Okay, let's aim for 1 hour. We just need to clean up here. Okay, let's clean up here. Head. If before next is null, head next is node 2. Head next is save. Okay, oh my god. 2, 1, 3. Why isn't this not correct? Oh, back with my console red line. Okay. Okay, so node 2 is apparently null here. So what's that? So 1 and 2. 1 2 2 3 3. So why isn't it connected? Before else return node 1. Node 1 would be 2 2 1. Is head no longer pointing at 1? Is that? That cannot be. Oh, I don't understand. So head next is node 2. Okay. Okay, I felt like I almost gave up, but at least I got there in the end. Oh, okay. Let's refactor. Well, before I refactor, so this is only one pass. And we're moving pointers. So time complexity should be linear. And what about space? We are only using constant space. Okay, linear time, constant space, which is pretty good. And this is also the follow-up. Could you do it in one pass? Which is usually the more difficult solution. And I actually didn't even think how I could do it in more than one pass. Okay, let's try to refactor this because we already spent so much time. So this part is to get to the beginning of the reverse list. We have 1 and 2 pointers starting from null. This is the process to reverse the linked list. We are saving the next one, reversing one pointer, and then stepping forward. We can remove our console red line. So we should be able to refactor this part. Okay, if before next is not null, which means when would before next be null? That should be when left is equal to 1. So let's see if left is bigger than 1. Right, okay, so same logic. So when left is bigger than 1, before next, okay, that's the original example. So when left is bigger than 1, before next is node 2, and before next is, so before here, next is node 2, and before next is node 1. That's the first example here. And we can also return head. If left is equal to 1, that means we do not have this part. We just start with reversing part. Then we do head next is node 2, and we return node 1. Okay. Wow, the logic seems so obvious when I have refactored now, but somehow it was really messy before. Okay, it's refactored, it looks better, but it seems to be quite slow. Even though this is one pass, I wonder why that is. I don't think I could improve anything here. Okay, so this is it. This is my solution. Let me just and then let's just have a look at other solutions now. Okay. Oh, it's cute. Okay. Oh. Okay. Recursive. So this is a little different. Tail next, tail next. Okay, I'm gonna look at one more, and I really need to take a break before I can focus another hour. 4 pointers. Okay. Dummy node, head, pre. It seems like they didn't need to do whatever that I did in the end. Start next. Then Okay, I need to take a break, drink some water, and actually get some air before I can try to understand this, which is gonna take more than 5 minutes. So I just can't do it right now. Alright, what can I do?